have your X is a random variable, and then we have the definition. What is the definition for random interval? So random interval is normally, it is just interval whose endpoints are random variable. Okay. So why we call this one as random variable? So normally you have X, and then at your endpoint, we have your X bar. Okay. So it also relate when you have your endpoint are statistics. Statistic maksudnya you have your X bar, you have your sample mean, sample standard deviation, sample variance. So that one are statistic. Okay, kalau let's say if we refer to population, we call that one as a parameter. Okay, parameter that's mean your mu, your sigma square, and your pi for proportion. That one is your parameter. What we do is we estimate your population parameter by taking a statistics value based on your observation. So when we construct interval estimate, so you have lower limit and also upper limit. Okay. So again, you have two-sided confidence interval. So this is the way how we write lower confidence interval. Okay. So this one is your upper confidence interval. So probability that your parameter lies between your lower limit and upper limit is the probability is 1 minus alpha. So 1 minus alpha is actually your confidence coefficient. Okay, confidence coefficient. So for example, let's say this one is coming from normal distribution. So normal distribution, your standardized form is S bar minus mu over sigma over square root of n. So let's say we take, it lies between minus 2 and 2. Okay, minus 2 and 2. So approximately the probability is 0.954. So that's mean this one, after we expand and then we simplify, modify algebraic form, so we get lower point or lower interval. Okay, x bar minus 2 sigma over square root of n, x bar plus 2 sigma over square root of n. So this one is called as random interval since our endpoint is a statistic. Okay, because we have here is your x bar. Okay, so K sigma dia, K sigma is known. Okay, sigma diketahui. Okay, so that one lah. So again, for confidence interval for a single population mean, we have several cases. If you remember back, we have 3 cases actually. So first case is sigma square is known. Okay, sigma square is known regardless of the population size. It can be either large sample size, which is n greater than 30, or you can also have small sample size as long as your sigma square is known. Okay, maksudnya diberi daripada soalan. We don't have to estimate your sigma square. If you want to estimate your sigma square, that means we need to use sample variance, which is your S square. Okay, let's say we have your X bar here is the MLE. Okay, so we have the standard form that we know that from your sampling distribution. Okay, X bar is normally distributed with mean mu, variance, sigma square over n. Okay, so given your standard form is S bar minus mu over sigma over square root of n, this one is normally distributed with mean 0, variance 1. Okay, standard normal. So probability is 1 minus alpha. So that's mean probability the area under the curve is 1 minus alpha. Okay, so here, not area under the curve, total probability is 1, okay, area under the curve. So since we have the parameter mu is between minus z alpha over 2 and z alpha over 2 is 1 minus alpha. So the balance here is alpha over 2 and alpha over 2. So that's why in your question, we have the value for alpha, and then if you want to find from your stats table, normally we have here is alpha divided by 2. Okay, so here let's say you want to construct your confidence interval. Okay, so for the probability 1 minus alpha, we can find z alpha over 2 such that we have x bar minus mu. Okay, normally we start by writing, let's say negative z alpha over 2. Okay, less than z, and then z alpha over 2. The probability is just 1 minus alpha. Okay, 1 minus alpha here. Okay, so z is between minus z alpha over 2 and z alpha over 2. The probability is 1 minus alpha. So z replaced with x bar minus mu over sigma over square root of n. Okay, so kita modify kan. Okay, so dalam kamu punya jalan kerja, kamu tunjukkan cara mana, bagaimanakah kamu modify dia punya tu, expand and then simplify kan. Jangan terus bagi jawapan dalam bentuk yang ni jangan bagi yang Last kali ni. Okay, kalau tidak kamu skip dia punya step here. Markah kat sini. Kita ada allocation markah for that one. Okay, so daripada sini kata jam sini tak dapatlah markah kat tengah tu. Okay, you miss some points lah. So that's why you want to simplify this one. So bring this one left side, right hand side. Okay, so write down x bar minus mu less than z alpha over 2 sigma over square of n. So simplify kan. So that's mean you have x bar minus z alpha over 2 sigma over square of n less than mu. Okay, so the same thing here. Okay, kita ada s bar minus mu greater than minus z alpha over 2 sigma over square root of n. So rewrite balik. Okay, and then you rearrange back the inequality. Okay, so it rearrange back the inequality. So it give you this one lah. Susun balik and then you get lah what is your lower limit and also your upper limit. Okay, itu dia punya konsep dia. Case dia sigma is known ataupun sigma square is known. But we consider here your x bar is the MLE for mu. Ya, maksudnya kita dah ada random sample, kita dah ada coming from normal distribution, you have unknown mean mu, but you have known variance sigma square. So your x bar is the MLE for mu. Okay. So in this case, you have lah, kita punya endpoint tu adalah statistic since your case sigma square is known. So it is a random interval. Okay. So as I mentioned before, you need to find the value from your stats table because you have the first question is normally derived. Okay. After that, using that formula that you already derived, solve the application. Okay. Solve the problem. So let's say you have here is your S bar. We have a random sample size 20. Okay. Normal with mean mu, your variance is 80 and your X bar here is given as 81.2. Okay, carry out the information. So X bar from the question is 81.2. Okay, so you have parameter mu is your unknown parameter mu. So that means you want to find your interval estimate for mu. Okay, so given is your sigma square. Ini sigma square dia. So your sigma square is equals to 80. Okay, let's say we already derived the formula. So we already know here, case is sigma square is known. Okay, so why? Because it is already given. Okay, sigma square is known. You don't have to estimate your sigma square. Okay, so that means the formula that we will use is this one lah. You will have x bar plus minus z alpha over 2 sigma over square root of n. Okay, your x bar. Okay, so first find what is your alpha. Okay, kaedah yang sama. Remember back what you already learned in your first year. So 1 minus alpha is 0.95. Okay, kalau tak ada, find from your Google lah. Search dia punya value dia. So alpha is 0.05. Okay, alpha is 0.05. You want to find alpha divided by 2 So 0.025. So from your stats table, find the value 0.025. Okay, kita ada Z alpha 0.025. Okay, if you check from your stats table, it should give you 1.96 Okay, you should get 1.96 here. So replace back x bar is 81.2 plus minus 1.96 and then sigma. Okay, here is your sigma square. So you can square root 80 divided by your n is 20. So simplify kan. Okay, dapatkan dalam bentuk lower limit and also your upper limit. Okay, it depends on either you want to use normally 3 lah. Kalau let's say 3 decimal point ataupun 4 decimal point. Okay. So itu macam mana kita solvekan menggunakan method yang dah ada lah Formula dah ada. Okay. You just derive that one. So it depends whether your formula that you already derived is correct or not lah So case sigma is known. So you have x bar plus minus z alpha over 2 sigma over square root of n. So just ganti je. Alpha dah ada. Find alpha over 2. So z alpha over 2 which is 1.96. Okay. So itu direct je Okay. We look at the second case. Nanti selesai kan bagi dia punya jawapan akhir dia. Okay, double check lah dengan jawapan saya dekat sini ni. Okay, you have 77.28. The other one, your upper limit is 85.12. Okay. Okay, second case. Okay, before we proceed with T distribution, okay. There is several notation that you need to know. Dia punya formula lah, formula. Okay. If you have your X is normal distribution, okay, normal, mean mu, variance, sigma square. So sigma square greater than 0 because this is your variance is always positive. So let's say we define a random variable W, X minus mu over sigma. Okay, ini kita dah tahu. Dia adalah standard normal distribution. Okay, standard normal distribution. So the same thing, kalau X adalah normal juga, cuma kita kuasa dua kan. So that's mean we have W square. So katakan W square tu adalah V. Okay. X minus mu square over sigma square. Ataupun dalam erti kata lain, X minus mu over sigma square kan lah. Okay. When we square the standard normal, it will become a chi-square distribution. Chi-square ni you already learn. Dah ada dah dalam first year. Chi-square distribution. But maybe you didn't know how it relates to standard normal. Okay. Actually, if you have a standard, not standard normal, okay, normal distribution, X minus mu over sigma, your standardized form, okay. When you square that one, it will become a chi-square distribution. So remember that chi-square distribution, you have a degree of freedom. Okay, kalau dalam stats table, you have degree of freedom. Taburan dia. So degree of freedom here, if we have X minus mu sigma square, it will become chi-square with 1 degree of freedom. Okay, with 1 degree of freedom. So let's say, katakan saya define another variable lah, katakan, apa simbol nak pakai ya? So you have, so, katakanlah ya. If I have S lah, for example So katakan summation. Summation xi minus mu over sigma and then I square this one. Okay, I is equals to 1 up to n. Okay, let's say I have this one. So this one is also follow chi-square distribution, but you have degree of freedom is n. Okay, ini kena take notes Kalau kita ada X minus mu over sigma square, degree of freedom dia 1 sebab 1 je random variable. But if you have summation from I equals to 1 up to n for your xi, you have S1, S2, Sn all together, you will have chi-square distribution with degree of freedom n. Okay. So itu konsep dia. Bila kita ada standard normal, kuasa 2 kan, it become chi-square. But if you have n variable, okay, so again, this one you will have chi-square with n degree of freedom. Okay, so this is how you want to construct T distribution. Okay, kalau T distribution, it is actually a combination between normal distribution, standard normal distribution, and also chi-square distribution. Okay, let's say if we have random variable W and we are independent. Okay, independent, that means the probability you can multiply and so on lah. Okay, so a new variable T is defined as TW. So maksudnya W kamu, normal kamu distribution standard normal, divided by square root V over R. Okay, V ni adalah chi-square distribution, this one. Okay, divided by degree of freedom R. So this one will distribute as T distribution with degree of freedom R. Okay, so kalau random variable T, standard normal, bahagi dengan square root V, your chi-square distribution. So kalau chi-square distribution, dia ada degree of freedom. So that's why T distribution tu dia ada degree of freedom. Kalau normal distribution tak ada. Kamu just find from your alpha and then from what is the probability. Okay, but this one, you need to find for T, you need to have your degree of freedom. Okay, so itu tak berhenti lah ya. So the same thing, kita nak construct a probability for 1 minus alpha. So we will construct your variable T is between minus T alpha over 2 and also T alpha over 2, the probability is 1 minus alpha. Okay, itu dia punya konsep dah ya. Okay, kita tengok ini, case 2 ya. Okay, already case 2 ni saya rasa kita dah explain in detail jugalah dalam kita nota tu. Okay, so case 2, when you have sigma square is unknown. So sigma square is unknown, but you have a small sample size, which is n is less than 30. Okay, when you have small sample size and sigma square is unknown, that means you need to estimate your sample variance. Okay, so katakan x1, x2, xn is denote a random sample of size n from a normal distribution with unknown mean mu. Okay, consider that x bar is the MLE of mu. Okay, so itu mesti ada dalam kita punya explanation. Suppose that we do not know the variance sigma square. Okay, maksudnya consider x bar is the MLE of mu with, nak ringkaslah ataupun kasihlah ya. Sini, with unknown variance. Variance sigma square. So ini tak perlu tulis lah kalau kita tulis situ. Okay. Let x1, x2, xn denote a random sample of size n from a normal distribution with unknown mean mu and also unknown variance sigma square. So consider x bar is the MLE of mu. Okay. So note that okay, kita ada n minus 1 s square over sigma square is distributed as chi-square with n minus 1 degree of freedom. Okay. Kalau kamu refer pada kamu punya stats table, okay, stats table yang terbaru lah ya, kita ada list of formula. So chi-square is the same thing if you write n minus 1 s square over sigma square. Okay. Nanti dah baca ya, tengok dalam ni kalau ada stats table, refer back. Okay, you have the list of formula kat depan tu. So n minus 1 s square over sigma square is your chi-square distribution, but it is distributed with n minus 1 degree of freedom. Sebab ini kita ada n minus 1 ya. Okay. And then, where your s square here, ini sample variance ni. S square, this is the formula for your sample variance. S square is given as summation xi minus x bar square over n minus 1. So this one is the variance of a random sample of size n from a distribution that has normal with mean mu and also variance sigma square. Okay, so that one so kita ada n minus 1 s square over sigma square is chi-square distributed with n minus 1, and then s square tu adalah summation xi minus x bar square over n minus 1. It is a variance of random sample from the normal population yang ada mean mu dengan variance sigma square. Okay, so now we have standard normal here, x bar minus mu over sigma over square root of n, dan juga n minus 1 s square over sigma square. Okay, and these two random variable, so katakan ini tadi w, okay, this is your v lah ya. Okay, v, this is your w tadi. Okay, let's say you have two random variable, w is x bar minus mu over sigma over square of n, and also v is n minus 1 s square over sigma square. So these two are stochastically independent. Okay, that means that's not related to each other. Randomly lah, stochastically independent. So these two random variable are independent. So let's say we define a random variable t. Okay, define the RV random variable t. The random variable t. Okay, such that t is given as the ratio of w. Okay, divide by square root of v divide by r. Ini ini. W standard normal kamu divide by square root of v, kamu punya square tadi divide by degree of freedom. Okay, here. W, this is V, degree of freedom dia, N minus 1. Okay, kita ambil ratio dia. And then kita simplify kan. So, simplify kan, baru kita dapat formula ni. Okay, ini formula yang kamu pakai dalam sampling distribution tu. Yalah, yang awal tu. Okay, when you want to testing your hypothesis, finding your confidence interval, this is the formula that you use. Okay, so S bar minus mu over sigma over square of n divide by square root n minus 1 S square over sigma square divide by n minus 1. Okay, kita simplify kan. So let's say here, okay, ini cancel out n minus 1. Okay, square root sigma square ni, dia cancel dengan yang ni. Okay, square root S square ni, square root kan, dia akan jadi S lah. So, susun balik, you will have X bar minus mu S over square root of N. So, this T distribution will have N minus 1 degree of freedom. Okay, kita ada N minus 1 degree of freedom. So, that is your random variable. Random variable T tu. Okay, dah dapat random variable T tu, baru kita construct dia punya confidence interval. So, that means the information here, dia akan diberilah daripada soalan tu. Let's say X1, X2, Xn is a random sample of size n with unknown mean mu and unknown variance. So consider that your S bar is M like E. Okay, we know that, note that n minus 1 S square over sigma square is distributed as chi-square with n minus 1 degree of freedom. Where you have your S square is summation Si minus S bar square over n minus 1 is your variance. Okay, construct the ratio of these two random variable. Okay, that's mean kamu punya ni. Standard normal ni, X bar minus mu over sigma over square. Ataupun show that kita dapat this one. Pun boleh jugalah macam mana kita nak set up dia punya soalan And then you derive lah. Dalam kamu punya explanation, you need to have, biasanya this one. Okay, ini daripada sini. Okay, sampai sini ni diberi daripada soalan. Okay, so you need to write here. Ini. Okay, note that let's say you have a random variable W, X bar minus mu over sigma over square of N is a standard normal. And we have the random variable V, which is N minus 1 S square over sigma square is a chi-squared distributed as N minus 1. And then W and V are two random variable which is stochastically independent. Okay, so define the random variable T such as the ratio is given as, this one lah, kamu ada W divided by square root of V divided by degree of freedom dia. Simplify kan. Okay, now kita construct dia punya confidence interval. So for the probability 1 minus alpha, we can find a number T alpha over 2n minus 1 such that, okay, sebab kalau taburan T pun dia lebih kurang macam standard normal jugalah So kita ada kat sini minus T alpha over 2 cuma degree of freedom. This one lah, T alpha over 2 n minus 1. Okay, so start by replace kamu punya ni lah, probability macam tu, n minus 1 less than T less than, nampak ke, n minus 1, this one sama dengan 1 minus alpha. Okay, sama dengan 1 minus alpha. So this one. Okay, and then again here, kita akan rearrange back. So X bar minus mu. So S over square of N, bawa sebelah kiri, bawa ke sebelah kanan. Okay, so rearrange balik. Tunjukkan, katakan ini. Ini 1 So let's say X bar minus mu less than T alpha over 2 n minus 1 S over square of N. So X bar minus T alpha over 2 n minus 1 S over square of N less than mu. Okay, ini katakan 1A. Yeah, the same thing. Kamu ambil X bar minus mu greater than minus T alpha over 2 n minus 1 S over square of N. So susun balik X bar plus T alpha over 2 n minus 1 S over square of N. Okay, ini dia akan jadi apa? Greater than mu Okay, 1B. Okay, jap. Okay, Okay, rearrange the inequality. Okay, we'll give you this one So kita susun balik this one. Okay. Probability X bar minus. Alah. S over square root of N sama dengan 1 minus alpha, teman. Okay. So, bila kamu dah susun semua ni, maksudnya kalau nak split kan, instead of tunjuk macam ni kat sini, okay, tunjukkan dulu 1A, 1B, and then rearrange back the inequality, susun balik, then, okay, it will give you this one lah. Okay, so that means this is your confidence interval estimate. So that means you will have X bar plus minus T alpha over 2 N minus 1 S over square root of N. Okay, so the confidence coefficient dia adalah 1 minus alpha. So that means your parameter mu lies between X bar minus T alpha over 2 N minus 1 S over square root of N and S bar plus T alpha over 2 N minus 1 S over square root of N. So that's means from your data set, okay, you need to find what is your X bar and also what is your value for your S. Okay, sample standard deviation. Okay, so kat sini kita ada T Okay, so ini dia punya introduction ni lah. Macam mana kita nak start. Okay, dia punya random sample, what is the distribution that involved. So we have the W standard normal, V is the chi-square. So take the ratio will define your random variable T, which is W over square root V over R. So this is the simplified form. So now you want to construct a confidence interval for 1 minus alpha. Okay, so start by writing minus T alpha over 2 less than T alpha over 2. The probability is 1 minus alpha. Okay, and then start lah. Rearrange kamu punya inequality, modify. Okay, lepas tu susun balik. So this is the last formula that you will have.